Welcome once again to Pt5 International College. Please kindly subscribe to this channel, like the video, share to your various colleagues in the various schools. We are still on chemical bonding. In case you need any extra tutorials, you can contact me on 059-1994-695 or 020-74-32271. You can search me on Google. You will get our school, Pt5 International College. My number is there, so you can call me for any tutorial service, especially my dear Form 1s who are coming home. I'm always available for you. And the final year students, I'm always available for you. You can call me and contact me for any related subject. Alright, let's continue with our study. In our previous video, we said something related to ionic bond and we explained the concept lattice enthalpy. If you have not watched that video, kindly watch the video and get the concept. In today's video, we are going to talk about another type of primary bond known as covalent bond. So today, I want you to understand this concept very well. Under these covalent bonds, we shall be looking basically at the various types of covalent bond you are supposed to be familiar with. The very first one, we call that the polar So, in this video, we are going to look at one of them. We have the polar covalent bonds, non-polar covalent bonds, and dative covalent bonds. So these are the various types of covalent bonds. And we already said that the covalent bond is an example of a primary bond, which is a type of bond. Okay, so what at all comes into memory when you hear the word covalent bonding? Just like we discussed in ionic bonding, we said that anytime ionic bond is formed, it's formed as a result of the total transfer of electron from one species to the other. But when it comes to covalent bonding, there is always sharing of electron pair. So in covalent bonding, it is the electrostatic force or it is the force of attraction that exists as a result of the sharing of electron bonds. So it means that when it comes to covalent bonding, we share the electrons. Now, why the name polar covalent, non-polar, and dative covalent? Now, polar in the sense that when you say something is polar, it means there is polarity. There's one partially positive, one partially negative. So, when you pick something like HCl, this is partially positive, this is partially negative. So why the polarity? Electrons will be pulled towards the most electronegative element. So in this polar or in this sharing, there is an unequal sharing of electron pair. Anytime there is an unequal sharing of electron pair, that type of covalent bond is called a polar covalent bond. Anytime there is an unequal means that the sharing was not done equally. For instance, when we are sharing an amount of money, let's assume we are sharing 10 Ghana cedi, and someone is giving 7 cedi and another person is giving 3 cedis. It means that there have been unequal sharing. But if you are sharing 10 cedi and someone donates or someone is giving 5 cedi, another person is giving 5 cedi, then we can see that there have been equal sharing. So non-polar covalent bonding also occurs as a result of the equal sharing of bond pair electrons. So that is the main difference. In this video, we are going to concentrate on these two, so that in our next video, we can concentrate on dative covalent bonding. The dative comes with its own name, especially my young boys who are dating young ladies. They donate a lot of money to them in the name of love. So that is how come we had the name dative. We'll talk about that. Alright. So let's look at the polar covalent bond, for instance. We have already said that anytime there is sharing of bond, we use a concept which is the octet rule. We have done that in the previous videos. But in this video, we are going to use this concept to explain how the pairs are shared. So looking at this hydrogen chloride, we know hydrogen already has one electron at each atom. So in terms of sharing, we have this is having one, and if this is our hydrogen and this is our chlorine, this chlorine has 7. So you realize that for them to be stable, they need to share this to form a bond. So this will prefer to share this with this, and that is why we say sharing. Look at this, they prefer to share. So this is having one here, and then there's another one here, they've shared. So that is the one. Now the others are having this. So you can see that this hydrogen has managed to share its electron with the chlorine. The chlorine has also shared the one with this, so that this hydrogen will be also full. Because if hydrogen gets 2, it is stable in nature. So you realize that these two will now come together as hydrogen chloride. Now the bond existing between this hydrogen and chlorine is what we call polar covalent bond. Polar in the sense that their polarities, this is partially positive, this is partially negative. Right, and this will also lead us to a very nice concept, which anytime we have an ionic bond, there is some nature of covalency in that ionic bond. And anytime there's a covalent bond, there's some nature of ionic, like a donation. And that will lead us to what we call polarization, polarizing power, and polarizability, which we are going to look at in our next video. So, in this video, let's concentrate on how to use the level dot structure to explain how these bonds are shared when it comes to the non-polar. So we can get some other examples of the polar covalent bonds. For instance, let's assume I have chlorine, another chlorine. These two elements will prefer to come together as stable entities. So what are they supposed to do? They need to share their electrons so that they can exist on their own. And anytime they are existing on their own, that is what we call molecules. They want to exist as gases, to be free, move freely. So how is this possible? Now look at chlorine. Chlorine has atomic number 17. So in writing the electronic configuration, 1s2, 2s2, 2p6, 3s2, 3p5. So this is chlorine. We have already said that anytime we are dealing with bonding, we don't use the core electrons. We only use valence electron. So we ignore the whole of this. We are only interested in this, the valence electron. This is having the same atomic number. So the outermost electron for chlorine is 5 plus 2, so it's 7. So we are only interested in the last aspect of this in chemical bonding. So this will go off, that the 4 electrons is taken off. So we now have 3s2, 3p5. This is what we are using in the bonding. So let's look at this. Chlorine, using the dot structure, we have 1, 2, so 4, 6, 7. So this is the chlorine according to the level dot structure. Then there's another chlorine. The same thing is happening here. 2, 4, 6, 7. Now these two would like to share this very one. They would like to donate each, bring one and bring one, so that we share, so that we can form a stable entity. So this One will bring one, this will also bring one. They are not sharing this. So you can see this is the chlorine having the 2, 4, 6. Now this one has been shared. This one has also been shared here. So the others is also having this 2, 4, 6. So if you want to check from one side of this is 2, 4, 6, 8. It's stable according to the octet rule. If you want to check from this side, it is 2, 4, 6, 8. So we can now write this chlorine as Cl2. What it implies is that now this chlorine is having a bond with this chlorine, and this is called chlorine molecule or chlorine. This is chlorine gas or chlorine molecule, and this is a stable entity, and this is what we call a non-polar covalent bond. So you can see a non-polar covalent bond is a bond formed as a result of what? The equal sharing of bond pair electrons. You can try examples like oxygen gas and then nitrogen gas. When you're able to do that, you realize that this will have something like this. Try it. If you're able to do that, give me a response in the answer section, comment section that yes. If you do this work, you get something like this. Write the answer in the comment section. Thank you for watching this video. Subscribe to the channel, like and share. See you in my next video.